So the remaining videos in this section are now moving the focus over to you being the network administrator. And at minimum, you have access to the default gateway that employees are using, or maybe a subset of your employees are using to access the internet. Okay? So for example, maybe you're a large corporation and you actually have separate network admins. There's a network admin who deals with all the payroll department and their networking stuff, and the HR department and their networking stuff. So we're going to assume that that's you. You know, the human resources department is large enough that they have their actual own networking administrator that controls their default gateway and everything else, and that's you. And so now they start complaining that they're losing internet connectivity, and it's your job to figure out if it's the default gateway at fault or something else higher up the chain. Now, because this is, like I said, the title of this video series is Basic Network Troubleshooting, clearly I can't cover every possible reason or cause that could lead to internet disconnectivity. So I'm just really going to try to focus on the easiest and most likely things to spot. So in case you've never seen this term before, SOHO, that stands for Small Office, Home Office. That's what that stands for. Now, what exactly is a small office? It's kind of vague, right? Is it 2 people? Is it 200 people? Small, medium, or large, that's up to you to decide. Now, like it says, if you've got a small office and it's set up and everything's been working just fine and chugging along, kind of unlikely that just out of the blue, network connectivity is going to stop. Okay, that usually doesn't happen. Not for no reason anyway. Now, if the network does go down, it's usually because of one of these 5 bullet points right here. So for example, a configuration change that went wrong. So you as the network administrator legitimately got into a networking device because it was time to make a change, and you didn't quite know what you were doing, or maybe you forgot that typing in this command had this additional effect, and everything went kablooey and everything went down. That could happen. Introduction of new equipment that triggered a fault. Some possible reasons for that. For example, let's say a new host, a new laptop joins the network. It's not a new laptop, it's new to the network, but maybe this is a laptop that's old, it's been around for a while. It's something that an end user actually owns, but guess what? That laptop has a virus on it. Hey, isn't that fun? And now when it connects to the network, it infects your network and starts bringing stuff down. So that's an example of a new equipment being added to the network that causes failures. Introduction of devices that trigger the BPDU guard error. So for those of you who are studying your CCNA, you've probably learned in the world of switching that there's something called BPDU guard. So in the world of switching, we know that switches run a feature or a protocol called spanning tree. And I'm not going to get into the details of that, but spanning tree is designed to prevent bridging loops. Now, a byproduct of spanning tree is that if my laptop connects to a port on a switch that's running spanning tree, the default behavior is my laptop is going to have no connectivity for almost a minute. Takes a while. So that could irritate some people. So sometimes what network administrators will do, this is very popular, is they'll turn on that interface on the switch, something called port fast. Think about that. Fast port fast, meaning as soon as somebody connects that port, boop, it goes up. It's now open, wide open. It sort of bypasses the whole spanning tree security checks and becomes wide open for networking. Now, the same network admin that added the port fast feature to that interface, they say, okay, let's see. This interface here goes to a training room. And while there's going to be people in there with laptops and stuff, there really shouldn't be any networking devices in that training room. There's no reason for there to be routers or switches in that training room because I control all the routers or switches and I didn't put one in there. There shouldn't be one in there. So the network admin says, okay, in addition to port fast, I'm going to add another feature to this interface that goes to that training room called BPDU guard, which means if all of a sudden some spanning tree messages start coming in from that room, that means somebody put a switch in that room. And there's not supposed to be any switch right there. So if that switch starts sending messages, which are called BPDU guard or BPDUs, I'm going to guard against that because that's not allowed. So BPDU guard says, look, if spanning tree starts sending BPDUs, bam, shut down that port, kill it, because that's unauthorized. So that could cause a fault. That could cause it. Something else, every single device, whether it's a laptop or a server or router or switch, they all consume electricity, right? So let's imagine that I've got a whole slew of devices, let's say in my networking data center, right, where all my routers and switches and stuff live. Let's say I got a whole bunch of them all connected to the same outlet, right? I've got an extension, for some reason the term just left me. But something that's got 4 or 5 prongs on it plugged into the wall, and I've got a whole bunch of routers and switches plugged into that same wall jack. Now, what happens if I connect a new router, a new switch, that now the total power that's used is overwhelming the circuit breaker in that wall? Guess what? Breaker flips, and now all those devices go down, which would certainly cause a lack of network connectivity. So that's another thing. Maybe you've overwhelmed the electrical consumption for that particular part of the building or that particular part of the wall. Or another reason where the introduction of new equipment could trigger a fault. Maybe everything's working along just fine right now, and I decide, okay, well, what I'm going to do is I've purchased another internet connection. So I got my primary internet connection, which is going okay, but I'm kind of irritated with that service provider. They've been having some problems. Their DNS server is unreachable half the time. I'm getting a little ticked off at them. So what I'm going to do is I'm going to purchase a second internet connection with somebody totally different. I'm going to test that for like a month. And if that's nice and stable, I'm going to fire these guys. I'm going to fire the other, and I'm going to move everything over to here. So what I'm going to do is I'm going to set up all of my internal routers and stuff to point to the new connection as the primary connection. Move away from using that guy. We'll still keep him for a month as a backup, but now point everything to the new service provider. Well, here's a problem you could have. Let's say I do that. I go to all my routers, my existing routers, and I say, okay, go to this router right here. I'm going to put in a new router, point to him, because he's got the preferred way out. So let's say I do that. But when I install the new router, he's not connected to the internet yet, right? Maybe for whatever reason, but there's a variety of stuff that has to happen between him and the service provider, and that's not working yet. And yet, he's now in place. He's telling all the other routers, hey, here I am, talk to me, I'm your way out. Now I've just caused network disconnectivity because now everybody's pointing to a router that his connection out isn't fully operational yet. So that's another example of introducing new equipment that triggered a fault. Environmental issues, right? Certainly power outages could cause network stuff. Somebody accidentally spills their cup of coffee on a router and short circuits it and electrocutes themselves. That could cause a network outage. All sorts of environmental issues. A room full of equipment becomes too hot and a router or switch just fries and turns off because it exceeds the maximum temperature. All kinds of stuff like that. Someone playing around in the data closet. You just hired a new network administrator. And you said, okay, why don't you shadow me for a while? Don't touch anything. But, whenever I go into the area here that's got the routers and switches, watch me. I'll type some stuff in. And now, you've gone home for the weekend or you're sick one day, and that new network admin says, oh, I think I could make things better. Let me go in here and boop, now they screw everything up and the network goes down, right? Someone's playing around. Or certainly, we can always blame the good old ISP, right? Connection to the ISP fails. The ISP is at fault. Now, in all these situations, we've got a common problem where employees in a certain section of the network, employees that belong to one group or maybe who sit in one common area, they start screaming that they've lost their connection to the internet. So that's the common problem. So now what we're going to look at is what sort of a state diagram I could follow, and we've seen a bunch of those already, that will give me a logical step-by-step process to try to reduce where the problem could be, isolate where the problem could be. Because remember, my first question is it on my router? Is it on this router that I control? Or is it on something else? So we're assuming that the users have already done troubleshooting on their laptops, right? They've already made sure that they're cabled correctly, they're connected to the Wi-Fi network correctly. It's presumably not them. So is it me? Is it my router? So common state diagram you'd want to go through. And I'm going to go through each one of these in detail. I'm going to have walkthroughs for each one of these that talk about why this might fail, how to identify it, and what troubleshooting commands you might want to issue to try to fix the problem, or at least identify what the source or root of the problem is. Okay, so step number one, you got to be able to get into that router, right? And see what the problem is. Now, what if you cannot get into the router? Okay, why do you not get into the router? Well, it's probably going to be one of two things. Either incorrect credentials, meaning it's prompting you for username and password and you're just not typing the right thing in, which is kind of suspicious if you are the network admin and you're not typing in the right password. That tells me something funny is going on. Or you can't get in at all. The console is completely unresponsive. You've connected directly to the console port of that router and nothing. And so we'll talk about why some of those things might happen. So let's say you can get into the router. You've got access to the command line. Next thing you do, because remember, you got people screaming in your ear right now, can't get to my website. So you got into the router. Are the relevant interfaces up? So you think to yourself, okay, what interface on this router leads downstream to these people who are complaining? Is that interface up? What interface leads upstream to the internet connection? Is that up? Now, if the answer is no, well, we definitely have to troubleshoot that. If the answer is yes, okay, we move on. Does this router actually have routes for the internet? Whatever routes it would need to get to the outside world, do those routes exist in the routing table? If the answer is no, we troubleshoot it. Now you might be thinking to yourself, wait a second, Keith, you're going through these troubleshooting things awfully fast. Remember, I'm going to have individual walkthroughs for each one of these things to sort of identify why an interface might be down, why we might not have routes for internet access. So I'm just going through the high-level picture at this point. Let's say I do have routes for internet access. So far I've verified my interfaces to my employees and my interface to my ISP is up. I've verified I actually have routes to get to the outside world. Can I ping Google's website? And this doesn't necessarily have to be 8.8.8.8. You could try pinging anything on the internet, but this is usually up, right? If you have an internet connection, I've never not been able to ping 8.8.8.8 when I have an internet connection. So that's a pretty reliable IP address. Let's say that you cannot troubleshoot that. Let's say you can. So once again, interfaces are up. I've learned about the appropriate route or path to get out. I've verified that from this router I'm on right now, I can ping that Google web server. Next thing is this router advertising upstream my employee subnets? Because remember, this default gateway here, not only do the employees need to be able to send their traffic to the internet, but they probably need to get a reply back, right? Maybe the reply back is at fault because maybe the subnet, the network that the employees live on, nobody knows about it. My router that's connected to that network has not bothered to inform the rest of the internet about this network, so there's no way back. If no, we want to troubleshoot that. If yes, okay, so now we're getting a little bit tricky here because now we have interfaces are up, check. I've learned about whatever routes I need to get to the internet, check. I've verified I can ping some internet destination, check. The internet should know of the way back to me because I've verified I am advertising the correct subnets. Check. So now I'm going to say, okay, maybe it's not a routing issue. Maybe it's something else. So I'm going to make this router pretend that it's an employee, one of the employees who's complaining. And then I'm going to try to ping that address again. So I'm going to create a loopback interface. So maybe John down here, right? John's got the IP address of 1.1.1.1. He's one of the ones who's lodged a complaint. So I'll go into my router, create a loopback address of 1111. And then from there, I'll try pinging that same Google address, but sourcing it from that loopback. So making it look like it came from the employee. Did that work? If no, troubleshoot. If yes, now I got to get the employee involved. I call up John. I say, John, see you lodged a trouble ticket here, a complaint. I've verified on my side that everything in this router looks like it's reachable. Could you try pinging this IP address for me? And either he will or will not be able to ping it. Either way, that's pretty much where the troubleshooting ends at this point. Because at this point, by step number 17, you've pretty much ruled out this router as being the problem. There could be other devices in your network that are causing the problem, but you've pretty much ruled out this particular default gateway as being the reason why people can't get to their websites. So now, in the subsequent walkthroughs, we're going to go through each one of these steps and figure out how to identify why this might be the problem and what commands can I issue to maybe identify the root cause of the problem.